This is about image recognition generally, and hopefully it's something that you'll be able to do, when you go home tonight. It's just 4 or 5 lines essentially. So yeah, it's just to dip your feet in the water, so to speak, of TensorFlow. All right, so image recognition is an easy problem for humans, but a difficult problem for computers, right? You take a 3-4-year-old, you say car, 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 by the 5th, 6th time, they'll be able to recognize a car. But you tell a computer this is a car, car, car without deep learning, without TensorFlow, without any of that, it's really, it plays with your minds. But, of course, images are an important part of, human communication. Picture is worth 1,000 words. And, we're here at PyData, and so much of data on the internet is made up of images. Instagram, Snapchat, Tumblr, whatever. And yet, there was, until now, without TensorFlow and deep learning, there wasn't an easy, scalable, programmatic way to extract metadata about images. So let's look at a very simple problem. Let's try to tell the difference between an apple and an orange, right? So we all know what an apple looks like, and we all know what an orange looks like, right? So let's say you guys are all Pythonistas. I'll throw it out there. There's no wrong answer. How would you approach this without TensorFlow, without deep learning? OpenCV. OpenCV, that's interesting, yeah? Anybody else?
Different color.
Yeah, that's a reasonable way to go about it. I don't know if you guys know about the PIL library in Python, the Python imaging library. That's something I was using before, TensorFlow. And it essentially goes through each pixel, and each pixel is allocated a number that represents a color, like the HTML color codes, and so on and so forth. So you could do something like this, right? You could have import PIL, and you could have a function, and it could be just for color, right? Or you could even get a bit more sophisticated and do one about texture somehow, or shape, or whatever. But then, this comes along, right? So, we all can kind of say, okay, as human beings, this is, I guess, an apple, right? But, as a computer, color is, you really don't know. And so, as developers, what we have to do is we have to design a function for that case. And there are thousands of cases like that. And with images, it gets really, really complex, right? Because the patterns are, very diverse. So in comes TensorFlow. And it does this, right? This is kind of a black hole. We're not quite sure what it does, right? If you look at the deep learning articles on the internet and stuff like that, with TensorFlow, you just substitute that for magic, and the article still makes sense, right? So I'm just going to throw it out there. There's no stupid answer. Everybody here tonight is far from stupid, right? I'm curious, as a developer and as a presenter, there are always interesting ways to look at this, because really we just abstract from something complex, right? And everything is an analogy. So what do you guys think TensorFlow does, right? Can I get any volunteers?
Apart from magic.
Apart from magic. Just a guess. I mean, it's not, how would you describe it in your own words? Can I get anybody? Tick-tock, tick-tock. All right. All right, so I'll just say how I perceive it. It's not necessarily the right way. And how, from somebody coming from Python, how I view it, right? And obviously, you could spend, not only a full lecture, but an entire course, many lectures describing it, and it's beyond the scope of this talk, right? And if you're interested, email me. My email's at the end. I can send you some resources for that. So essentially, these are the 4 kind of concepts you need to get your head around to kind of understand theoretically what TensorFlow does, right? There are tensors, there are operations, there are weights and bias, there's a gradient, and there's a gradient descent, right? So, I mean, if you want, there are inputs and outputs, right? And there are these operations in between. The input is a tensor, the output is a tensor, right? So you know how we were looking at this function, right? So this is a tensor. And you know how you return statements in Python? That is also a tensor. All right? And the operations are what's in between the DEF and the return. And the operation can be something as simple as addition, subtraction, multiplication, whatever. Or it can get really complex with a very sophisticated algorithm. But at the end of the day, it's always in tensor, out tensor. So what exactly is a tensor? A tensor is a multidimensional array, right? So think of it, as, a matrix is like a 3D matrix, really. And in each one of those kind of squares, there's usually a kind of number, right? So between and those tensors flow through different nodes, and there are the tensors themselves have the flow itself has a weight, and the node itself has a bias. So what that means, say we're programming in regular Python, right? So we're here, right? Regular Python, we do this, we have a return statement, and then we have a variable that is accessible globally, and then what we can do is we can call on that, or we send it to another function, right? We have a function here that calls it. In regular Python, it's very linear, right? This variable goes here to this function, that function. In TensorFlow, it's different. What it says is, hold on, I don't know where I'm going to send you yet, and I might send you to that function, or to that function, or to that function, right? And it all depends. It's open, right? Because the cool thing about TensorFlow, or deep learning generally, is it writes the rules for you. As developers, we tend to write the rules. That's the old school kind of developing, right? But, for something like image recognition, we go bonkers. So with this, the weights, where it sends that information, it's up in the air. And that really depends on this thing called the gradient descent. You can read more about it. But it adapts, right? So it says, okay, maybe we should send you here, we should send you there. And what it does is you have a bunch of data that's labeled, right? And you try to see, if you sent it that way, can it make a better educated guess with less error? So what happens with something like image recognition is these little operations tend to become kind of develop functions of their own, right? And that function, one of them can be, shape definition. Another can be color. Another can be something else. And they kind of develop these little functions on their own. And the cool thing about TensorFlow is you have like these thousands of functions working for you that you didn't even have to define, and that gets really complex and can solve something that is normally complex like image recognition. So that's my way of viewing things, but it's not necessarily the best one. Yeah, and of course this is the normal representation of kind of TensorFlow, with these being the nodes. And here this has a weight, and this has a bias, and then it can flow thousands of different ways. And why do we call this deep learning? Is because usually it's 3 layers, right? So it gets really complex, and you can have as many layers as you want theoretically. Yeah, and if you look at something that's even more basic, like recognizing handwriting, right? Which is a useful, very useful thing. You know, at this level, it can be letters, right? At this level, it can be words, and at this level, it can be combinations of words. And then you can kind of take shortcuts. So, you know, this is strong for the, and maybe the T wasn't written that well, so the T is weak, and it kind of figures things out. All right, so let's look at setting up TensorFlow with containers. How many people here have experience with containers or Dockers? Yeah, yeah. A lot of people have experience with that. So I'm going to give you one line, boom, TensorFlow done. And I mean, I'm on Ubuntu, Linux, so it's one line to install Docker, but you know, and then hello world Docker. But essentially, if you've got Docker running, it's this line. And don't worry about it. I've got plenty of, you know, the slides are going to be up and be shared, so you can. And that's a Docker image that's provided by TensorFlow. And then boom, it takes a while, right? And then you've got, it eventually downloads. And then essentially you start your Docker instance, attach, boom, you're a root. You have an image of TensorFlow. Second thing, creating a TensorFlow model from scratch is really kind of difficult. You need access to big data, and let's be real. As independent developers, unless you're working for a huge company, and even if you're working for that huge company, you may not even have access to that big data, right? So, you know, really creating a model from scratch is not really feasible for most developers. But thankfully, people are now starting to share models already. So what we have is not a deep learning. We have deep learning, but we have something even cooler, which is transfer learning. So people can borrow an existing model and then just build on top of that. And yeah, so what we're going to do is use a model called Inception, which has been trained with about 100,000 images, but it hasn't been made with every category possible, right? And one of the categories, one of the image categories that hasn't been used is flowers. It can't recognize flowers. So, and what we're going to do is we're going to look at 4 or 5 categories of flowers. Roses, tulips, dandelions, sunflowers and stuff like that, right? So you can, TensorFlow makes this available to you, right? So you can download a data set of flower photos. And it's only about 200, 300 photos. It's nothing. And so there you go, about, you know, 218 megs, right? And then boom, you've got your images. And the cool thing is that this image also gives you the Python script to retrain the Inception model. Because what we want to do is we transfer it and then retrain it on this new image data set. So you've got that retrain.py and all that, you know, legal mumbo jumbo over there. And just to give you an idea, and then voila. So here's the cool thing. So these are options, right? And that's the main thing. You call the retrain Python. And then you've got these options. So quickly, bottlenecks. What are bottlenecks? Okay, bottlenecks are essentially memcache. If you guys are web developers, you know, you're going to be using the same images over and over again. So it's going to take longer in the short term, but much faster in the long run. So the bottlenecks are just like a caching thing. How many training steps? You can have like up to, I think, 4,000 training steps. So and if you have like 4,000, it's going to take you days. This is just doing 500 training steps, and that only takes like 30, 40 minutes, right? You can go watch a show and it'll be done. And then so here you're saying, I want the Inception model to be used, right? And then where are the images that you're training it on? It's the image directory. And all you have to do is in the folder, you have to label it, say, sunflowers, and have photos of sunflowers. Or roses and photos of roses. It could be anything. It doesn't have to be, of course, flowers, but here we go. So what it does, it downloads in Inception, and it starts doing its thing. And here you see a bunch of different things, but don't be freaked out. We're going to get to that. So we talked about bottlenecks, training accuracy, validation accuracy, cross-entropy, and final test accuracy. So final test accuracy is how good it is in the end. That's pretty easy. Should be somewhere between 85 and 95%. Of course, there's no 100%. And then, so we have so training accuracy and validation accuracy. So this can be explained by the problem of overfitting, right? So you want something that's reliable and you want something that's accurate, but you actually want something in between. So you can do something that's credible validation accuracy, right? But has low train accuracy. So you just train on those photos and it won't be able to generalize. When you bring a new photo of the new flower, it won't really know because it just knows that specific thing. In deep learning, TensorFlow, it's called that problem is called overfitting, right? So you have that. So essentially, you go between that. And the key thing here really is cross-entropy. Cross-entropy is an indicator of how it's learning, right? So here, the cross-entropy is 0.34. And if we go back at the beginning, it's 1.53. So actually, if it is learning, it goes down. So that's a good thing. So that's deep learning in action. So yeah, and here you see the steps going, 499, 500 steps done, boom. All right, and the final test accuracy here is 89.8, but you know, so. And now we're gonna test the model with images, a live demo. Wish me luck. Okay, so the script is already there. It's called label image. Label_image.py, and it's in your instance, your Docker image, and of course you just give it that image, and then that's it. So give me a second. What I'm going to do here is I have a terminal, and I'm going to try to bring it. All right. Okay. Exit. All right. So we're going to go to Google Images, right? So guys, give me a word. Tulips, roses, sunflowers, dandelions. Anybody want to give me? We're going to pick a random image.
Rose.
Roses?
Yeah.
Okay.
Let's make it a rose.
All right.
Maybe in Polish.
Yeah, okay.
R-O-Z-E.
I-O?
R-O-Z-E.
Yeah, maybe. Roses. Yeah. So pick a photo of roses. Is it this one, or you guys pick? I mean, just to show you that I'm not, just saying whatever.
Lady.
The lady here? Well, you have to see the rose. I mean, obviously, this one? This bouquet? Yeah?
So maybe Guns N' Roses.
No.
Check how
So,
you can generalize this.
no, come on. I know it's getting late, but come on. Okay, so what I'm going to do is, all right. I'm just going to bring the terminal here. Sorry. Yeah, all right. And let's make that big, or not. It's okay. All right. Okay, just so you know, here's the random thing. What I'm going to do is I'm going to do a wget. I just pasted that. I'm going to paste that link. I'm going to be renaming the file PyData Warsaw. Warsaw.jpg. All right, done. So it's here, right? So PyData Warsaw. So what we're going to do is we're going to go PyData Warsaw. You guys are nice. You know, normally, previous presentations, someone said, I want a tulip, and I want a tulip that looks like a rose. And those are trickier, you know, just so you... All right. Da-da-da-da. It takes us a couple of seconds. All right, so see, roses, 0.98. I'm sorry if you can't see it. Let me... No. That's... There you go. I guess I can't... We can do another one if we have time or whatever. You can give me a tricky one, or we can call...
A yellow rose.
A yellow rose. Yeah, sure. That's actually an interesting problem, actually. Because could say it's a sunflower, right? Okay. This one?
The one in the bucket?
The bucket? Sorry, I missed it. Yellow rose. Which one did you want? This one?
Yeah, the bucket.
Yeah. You're the wise guy, huh? You're trying to make me look bad.
If an easy one.
All right. Okay, so I'm copying, pasting, and then what I'm going to do, wget again, right? Copying, pasting the thing, then call it yellow rose. All right, it's already saved. So what we're going to do, not PyData Warsaw anymore, yellow rose. Yellow rose. Fingers crossed. Da-na-na-na.
Does it look at the file name?
No? No. Oh, come on, man. PyData Warsaw, it didn't. So actually, this is an interesting problem because it's 60%, right? 0.609. It's still the highest one by far. The tulips is 0.16, right? So it's not perfect. But you know, for 250 images and for, you know, one line Docker installation, it's pretty cool, you know? So it's kind of magic in the end, you know? Anyways, that's my presentation. Thank you very much.
Thanks so much. We have plenty of time for questions, if you have any.
So,
Yes.
yeah, I'm happy to answer any questions. So this is my
We're going to
stuff.
join our after party.
Sure, with pleasure.
Yes, okay. Next question.
Okay, so this is kind of black boxy. So you get some input, you run the thing, and boom, you got your result. So first part of the question is, do you have some, or do you know some methods of making this thing less black boxy? I mean, for example, telling which parts of the original image, of the image that you tagged, contributed to the result. And the second part of the question is relates actually to the first step. Would it be a method to actually perform image segmentation?
Yeah, so yeah, definitely this is kind of black box. But you know, like in Python, you know, developers, we kind of are, you know, we have these growth spurts. Sometimes we stay all night, but sometimes we really want to be lazy and want stuff to be done for us, right? So this is kind of like, you know, a pip install for us, you know, and that's something we can play with, you know, really quickly. Naturally, you can tweak it, but at the end of the day, you know, it's the TensorFlow is going to tweak the things and the gradients. You can design it somehow. You know, you definitely can say, but in the end, it's going to be, you know, with Inception, what happens is that you're only actually dealing with the last layer. So Inception is just 100,000 images, but it's really good at, say, like shape detection, color differences. You know, so it's able to kind of maybe do a bit of image segmentation, but not as good as what's been done before. but if somebody's if there's a big color difference between something, it'll know that maybe that's an object that changes or something like that. So it goes through the layers, and that's the last layer. You can definitely, I've definitely played around with and use it for, at the end of the day, anything that's classification, right? So this, of course, is, I do another talk on generating stuff with TensorFlow, and that's really cool too. So you can look at data and you can kind of generate, you can look at music and you can generate music in that style. Or you can look at a piece of, like a Word document or something and generate writing in that style. So you can, at the end of the day, if you're doing a classification problem this pretty much can do the trick for most problems. But if you have a different kind of problem, if you're trying to create stuff, like generative, of course you have to use something entirely differently. But yeah. So.
Thanks. Another question?
Do you know of any other pre-trained models for other domains? So not just image classification, but
yes.
text mining or something?
Yes.
Language models pre-trained?
Yes, yes. Email me. I'm more than happy to send you some. There's one for sound recognition, right? So like kind of like Shazam, really. There's also a bunch of there's also Word documents, stuff like that. So you can even like kind of guess the writing style of certain people, right? So, but yeah, as images is by far the best. The biggest data sets, right? So that's why it's kind of an interesting problem to start with, because you have loads of data available, right? And the fact that you can, there's even like I'll send you if you want. There's a Chrome extension that'll allow you to just download all the Google Images search results. You can say download the 5,000 images or something like that, and boom, you have an image data set just like that, right? So that's pretty cool. Okay.
Okay, anyone? Okay.
Excuse me, did you ever play with the model's hyperparameters? Maybe with tuning these hyperparameters you can get better performance.
Yes, you can. The Inception model, if these people have, access to like, literally billions of images, that kind of approach is kind of like an old school kind of programming approach. It says, I'm still a developer and, I'm going to design the rules, right? And the thing with TensorFlow is you have to give up, right? A little bit, right? The rules are going to be written for you. So you can, the biggest differentiating factor in a TensorFlow model is data, period. You can tweak the hyperparameters. You can do a bunch of cool stuff, but if you have access to large data sets, that's what's going to make the difference.
Anyone more question to our guest? Okay, probably we're going to leave the rest of the discussion for the after party. So, applause, please. Thanks a lot for coming.